everyone, I'm Mohammed. I have been studying at Abdullah University for 3 years as a mechanical engineering student, and today I would like to talk about the truss systems and the method of truss system in static course. Why I am choosing this topic and why does it crucial topics in the static course? And this truss system topics is really crucial topics for especially mechanical engineering and civil engineering. And truss system you can see it everywhere, and such as building and bridges and roofs, whatever. Lots of structure of design and structure of the buildings. And truss system makes more strength of structure. And in the static course, when we want to solve the truss systems questions, we need to use two methods. The first one is method of joints, and the second one is method of section. And here we have a simple, not more simple, example here, and to understand more method of joints. And if you want to use method of joints, we have three critical steps. And the first one is find the global equilibrium. This means fraction of supports. The second one is select a joint sequences. And there's a hint here, do not pick a joint with more than two unknowns. And the third one is draw FBD of joints, use static equilibrium formula. And I just want to mention about FBD. This is really crucial and important, and it's help us to more easier to solve questions. We don't need to write and draw this geometric shapes again and again. And maybe someone who are watching me right now asking me, how can I make a difference between method of joints and method of section? I will mention them. And for the question, find the force in each member of truss and state whether in tension or compression. Guys, here we have, in the static course we have three formulas. Total moment equals 0, total Fy equals 0, total Fx equals 0. And here we need to use step 1. Find the global equilibrium reaction of force. We have two reactions. The first one is A and the second one is C. Start with them. And I would want to take a moment at point A. Total moment. It must be equal 0. And when we want to look to point A, is turning counterclockwise. It means positive. Let's start taking a moment with point D according to A. And 5 multiplied for its distance according to right distance A. It must be minus because it's turning the shapes in the direction of clockwise. And another one is 8 multiplied 3 at the B point. It must be minus again because it's turning the shapes in direction of clockwise. And again, Cy multiplied 4 is turning this way, means counterclockwise. It has to be plus. And here when we want to equal 0, we find the Cy equal 11 kilonewton. And if it is 11 kilonewton, the direction of total Fy must be equal. 11, this is direction, the positive direction in Y, and this negative direction in Y. And when we want to subtract them, we can find the AY is 3 kilonewton. And let's pass the second steps. Select a joint sequences. Do not pick a joint with more than two unknowns. We have to start with this question. The joint which has less unknowns, because we start with less unknowns and then we try to find unknowns each step by step. Here I choose this joint A and I draw FB here. Joint A we have AB and AD. We need to find them. Here, there is no such things. Okay, there is a. Here must be 5. This must be 5 kilogram. Because there's no such things except the forces here. This system. This is direction of positive x, 5 kilonewton. The AX must be 5 kilonewton because they are in equilibrium. And here, if we find AA 3 kilonewton here, the AD must be 3 kilonewton here. And then I would like to mention about point joint B, and I'm drawing a BD. Here, when we take point B, and we have to find BC and then BD. BC must be 11 kilonewton because of the here. How can I show it? AB must be 5 kilonewton and B must be 8 kilonewton, and this one is 11 kilonewton. We need to use the static equilibrium formula. Total Fx equals 0, and BC minus 5 minus 3 over 5, BD equals 0. And why is it 3 over 5? Because there is a special triangle at 3 and 4. This must be a right triangle. This distance must be 5. And another one is total Fy must be equal 0. And here, the first thing we find the BD, the forces of BD is 10 kilonewton, and then we get in here this equation, when we put here 10 kilonewton and BC is 11 kilonewton. And the last steps is joint C and FBD. Here, joint C, we found already the forces of 11 kilonewton here. And BC and CD, we find it again here, 11 kilonewton. Can write here. But it's not necessary for this equation. And here, we need to find these forces. According to total Fy must be equal 0. And 11 minus CD multiplies times 45 because here total distance 4 and here total distance 4. It must be 45 degrees, and CD equal 15.56 kilonewton. And we can write all of things here: AB 5, BC 11, AD 3, BD 10, CD 15.56. All things, all forces are tension. Tension means LA always, and the last one is compression. I just want to demonstrate the beautiful, but when we subtract this one and this one, it must be the result is minus. This means compression. And maybe you understand this topics how. And in the question asked us, find the force in each member of truss. And if your question asks you, find each member of truss system, you have to use method of joints. And otherwise, if your question asks, find the force in members GH, HE, and DE, it means this question asks special member. In this way, we have to use method of joints. The method of section means cutting. In type of this question, we are using 3 critical steps again. And step 1 is find the global equilibrium, we said, and reaction on supports. And second one is cut the members of interest, which members we need to use. And third one is draw an FBD of easy side. When we look at the question asks, find these special members. And when we draw in here and cutting here, we need to use section method because cutting here, and the first thing we need to start with the global equilibrium. It means taking moment. I want to take a moment at joint A, and here the direction of moment is counterclockwise. It means positive, and then it must be equal 0. And let's start with moment. Here Fy multiply 8 total 8. This must be plus because it's turning counterclockwise. And here 7 multiply 6. This must be a negative because it's turning the shapes in the negative direction of y. And here this must be again negative 4 multiply 4 is turning the shapes in the clockwise, and it must be again minus is turning the shapes again clockwise, 9 multiply 2. Here we can find Fy equal 9.5 kN. The first step is completed. And the step 2 and step 3, and cut the members of interest and draw a video of easy sides. And why the steps say us use easy side? Because when we want to force these members, we have two ways. Start with here and finding all members first here, these members of force of these members, and then coming here, or start with the F joints and then coming here to find the members of this, the force of these members. I want to use this side because this is the easiest side, and here we have three equations, three static equilibrium equations. Total moment equals 0, total Fx equals 0, total Fy equals 0 again. Start with the taken moment at joint A, joint E. When we want to take a moment, this direction of clockwise, counterclockwise, it must be plus. And then start with the joints. Here, Hg multiply 2, this is 2 meters, I didn't write. 2 meters, this must be minus because it's turning clockwise, and plus 9.5 multiply 2 is turning again counterclockwise. Hg equal 9.5 kN. We find it. And the second solution, the second equation, total Fy equals 0. And if we found it, and we can use it, 9.5 kN and minus 7 kN because it is in the negative direction in y, and minus He sine 45. Why is it sine 45? Because here 2 meters, here 2 meters, it must be 45. When we solve the question, solve this equation, He equal 3.34 kN is compression. And the last step is total Fx equals 0. And total Fx equals 0. We have 9.5 and plus 3.34 we found already. And we need to multiply cosine 45 here. Cosine 45 here, and minus dA. It is the negative direction of x. And here we can find the dA, 11.86 kN tension. This is the end of the topics. And again, I would like to mention, and if you want to solve the question of truss system, we have to equip two methods. The method of joint and the method of section. The big difference is your question asks if you find the special members, the force of special members, you need to use section. If your question asks, find all members in the Truss system, you have to use method of choice. This is easy. Thank you for listening. Stay healthy, stay your home. Thank you.